Hello, this is the first entry to a series of discussion videos about curve sketching. So let's get on with the first question. So for example problem number 1, it's asking us to explain why the following functions do not have a linear asymptote. So solution for sub-item A, where f of x is given by the following polynomial function. So we should show that it doesn't have any asymptote. So it should not have any horizontal, vertical, or oblique asymptote. To show that no horizontal asymptote exists for f, we should show that the limit of f as x approaches positive or negative infinity is not finite. Okay, so let us compute the limit of f as x approaches positive or negative infinity. So we can write this as factoring out x cubed, we end up with x cubed times 1 minus 3 over x plus 1 over x cubed as x approaches positive or negative infinity. So this is positive or negative infinity times 1. Okay, so indeed, the limit of f as x approaches positive or negative infinity is not finite. Therefore, f does not have any horizontal asymptote as required. Now let us also show that no vertical asymptote exists. No vertical asymptote. So to show that no such vertical asymptote exists, let's take an arbitrary real number a and compute the limit of f of x as x approaches a. However, f is a polynomial, and we know that polynomials are continuous everywhere. Therefore, this is just equal to f of a. But f of a is just a cubed minus 3a squared plus 1. And therefore, the limit, the absolute value of the limit of f of x as x approaches a, actually from the left or from the right, doesn't matter. Is just equal to f of a. And we know that this is always finite. Therefore, no such a in R exists such that limit of f of x as x approaches a from the right or from the left is equal to positive or negative infinity. Therefore, f does not have a vertical asymptote. Okay. Now, to show that no oblique asymptote exists. This is quite easy, as you may recall that if f of x is a rational function, so f of x is equal to p of x over q of x, where p and q are polynomial functions without common factors, then if the degree of p minus the degree of q is not equal to 1, then we can absolutely be sure that f does not have an oblique asymptote. So if we apply this result to f, now f of x is equal to x cubed minus 3x squared plus 1 all over 1. So this is equal to p of x over q of x, where p of x is equal to x cubed minus 3x squared plus 1, and q of x is equal to the constant polynomial 1. Then the degree of p minus the degree of q is just 3 minus 0, because the degree of a constant polynomial is always equal to 0. Therefore, since we know that, of course, 3 is not equal to 1, we can conclude that f does not have an oblique asymptote, or OA. Okay, so for sub-item B, so we are being asked the same question for g of x equals sine of x times cosine of x. Before we start, let us recall that sine of 2x is equal to 2 sine of x cosine of x. Therefore, sine of x cosine of x is equal to sine of 2x all over 2. So g of x can be written as sine of 2x all over 2. Or this will be a useful result for our computations. So let us show that no horizontal asymptote exists for G. So no HA. We should just compute the limit of G of x as x approaches positive or negative infinity. So this is just the limit of sine of 2x all over 2 as x approaches positive or negative infinity. However, sine of 2x is an oscillating function. Okay? So it just oscillates infinitely. It does not approach any particular value as x approaches infinity. Therefore, this does not exist. And therefore, limit of g of x as x approaches positive or negative infinity is not finite. And therefore, we can conclude that no g of x does not have any horizontal asymptote. So next, let us prove that g of x does not have any vertical asymptote. Let us compute the limit of g of x. Oh, no. First, let us take in an arbitrary value of a. So let a be any real number, and take the limit of g of x as x approaches a from the left or from the right, it does not matter. This is just equal to 1. Okay, so because g is continuous everywhere, of course, the sine function, as you may recall, is continuous everywhere. Therefore, the limit of g of x as x approaches a from the left or from the right is just g of a. This is equal to sine of 2a all over 2. And this implies that limit of g of x as x approaches a from the left or from the right is always finite, or it's always less than infinity. Therefore, there should be no horizontal, or there should be no vertical asymptote for g of x. Therefore, g of x does not have any vertical asymptote. Okay, now this is the hardest part of this exercise problem. Let us show that no oblique asymptote for g exists. Let us recall, we can't use the same result that we've used for f, because g of x is not a rational function. So let us recall that y equals mx plus b is an oblique asymptote for g if and only if the limit of g of x minus mx plus b as x approaches positive or negative infinity is 0. If any of these limits exist, then y equals mx plus b is an oblique asymptote for g. Okay, what can we derive from this? We can actually derive from this definition that the slope m is equal to the limit of g of x all over x as x approaches positive or negative infinity, and the intercept b is equal to the limit of g of x minus mx as x approaches positive or negative b. And so what we can do is that we should compute for this constants, and if we can show that if any of these two does not exist, then we can prove that no such y should exist as an oblique asymptote for g. Okay, so let's write that out. If any of these two does not exist, then g of x has no oblique asymptote. Okay, so let's do that. Let us compute for m. M is equal to the limit of g of x all over x as x approaches positive or negative infinity. And this is equal to the limit of sine of 2x all over 2x as x approaches positive or negative infinity. We can actually use the Squeeze Theorem to show that the limit of this function is equal to 0. Okay, so m exists, but does b exist? Okay. To compute b, we should look for the limit of g of x minus mx as x approaches positive or negative infinity. But the limit of g of x minus mx is just the limit of g of x, since m is equal to 0. But we already know that the limit of g of x does not exist. X approaches positive or negative infinity does not exist. Since b does not exist, at least one of these two does not exist, then there should be no oblique asymptote for g. Okay? So we have finished the first exercise problem. I'll see you in the next video.